Okay, good morning all. So today let us start with reduced syllabus. So as you all know that earlier board has reduced 30% syllabus from your portion, and now again the further reduced syllabus they have given. Okay, so now it is 20%. That means 50% of the syllabus is reduced for all the subject. I think all the teachers have discussed with you all, correct? Or no, not yet. No, okay. I'll inform them to discuss with you all. Okay. So let us start with the physics today to discuss about what all things is changed and what all things are not changed. So children, our first lesson in the physics is force. So in the force lesson, there is no change. So as it is, whatever lesson is there, as it is there, okay, there is no change. And then second is work, power and energy. Even in that lesson there is no change, so entire lesson you have to study for your board exam. Okay, now machine is the third lesson from your physics subject. In that, what there is a change, there is a small change, children, that is labor and simple treatment of labor, that is removed from your topic. Okay, this two subparts are removed from machine. So just note down or just tick down in your textbooks that these two subtopics are removed for your exams. Okay, so the next is the refraction of light at plane surface. If you see this, in this multiple image in thick glass, that is removed from here. Okay, so from refraction of light at a plane surface, multiple images in thick glass is removed. Next, refraction through a lens. From this topic, power, magnifying glass, simple microscope, find image, location and M from ray diagram. So this all things are reduced from this particular topic. Next comes spectrum. From spectrum, scattering of light is deleted. Okay, and in sound, characteristics of sound. From this particular sound chapter, this characteristics of sound is removed. Current electricity already we have finished, children. From that, derivation of series and parallel resistance is not there for your board exam purpose. Okay, so from the current electricity, this derivation of series and parallel resistance is not included. Okay, next, household circuits, house wiring, power distribution, staircase wiring. So these three things are removed. Okay, verification of Ohm's law is there, children. Okay, it's there. If you want, I will send you the further reduced syllabus copy. Do you want or you have? You have, or shall I send the soft copy? Okay, you can go through that also. You can understand what all things are deleted from that. Okay. Okay, no issues. If you have, you can go through. You can go through that. If you want, I will send also. No issues. I will send. No issues. Today I will send. Okay, house circuits, house wiring, power distribution, and staircase wiring is removed. And electromagnetism, as I have informed, total lesson is deleted from your portion. Earlier, only transformer they have deleted. Okay, when they have given the 30% syllabus is reduced, that time only transformer has reduced. So only I have not touched the transformer, but now the magnetic effects of current means entire topic they have omitted from your syllabus. Okay, and in heat, numerical problems on latent heat, only the problems of heat, that is particularly latent heat, is removed. Means 50% of the problem from heat lesson is removed. So this is your reduced syllabus, children. Okay, you can go through the portion which is given. If you don't have, I will send you today. You can go through that, and please, whatever it is there, don't neglect. Study regularly. As I have seen the paper, you have to study, and I don't know whether how you have attempted the papers. If you have honestly you have written the paper, then no issues. But if you have copied or if you are first gone through the question paper and then by-hearted and then written, children, no use. So be particular about whenever the question paper is given to you, try to write yourself. Then only you can prepare for your 10th board exam. Okay, so this is about the reduced syllabus. Any doubt in the reduced syllabus? Any doubt in the reduced syllabus? Can we go for the next? Children, can we start with the problem solving? A calorimeter is there. It is in which this will come? Calorimeter comes in heat only, no children. It is included in heat. Calorimeter is included in heat. Okay, that is there. I will send you this reduced syllabus copy also. Okay, it is there. Calorimeter is there. You can go through that reduced syllabus also. I have taken your main topics. So can we start with the problem solving now? Okay, so let us start with the problem solving, children. Can you see this? Work, energy and power. Is it visible on your screen, children? Is it visible? All subject reduced question. Okay, we'll send you all. Is it visible this? The slide is visible? No.
It is not.
Okay. Not visible. 1 minute. I think this previous slide only is visible to you all. Previous slide is visible to you all.
Yes, ma'am.
What I should do now here? Is it visible again? Can you see work, energy and power?
No, ma'am.
What is the problem?
Ma'am, actually, there is a gray color on that slide.
Just a minute. Huh? Chetan sir? Just a minute, some problem might be here.
Ma'am, now it is visible.
Yeah, I know that, but I have two different folders. See now.
Reduced syllabus chart is visible, but what you are going to show, it is not visible.
So the given things is given here. So now they have told us to find the ratio of their gravitational potential energy. So children, we know that the gravitational potential energy formula, that is mgh, mass into gravitational force into height. So for the body, when mgh is the formula, but h means we have taken your h1, so we have mentioned your h1, and now you substitute the value. Okay, mass is m only, gravitational is not given, so g as it is, and h1 means h, height is h is given, so h as it is. Similarly, for the second time, for gravitational potential energy of body 2 is again the formula mgh, but h means we have taken h2 height here, and h2 is nothing but 2h. So substitute the value 2h here. So now the ratio we have to find out. The ratio of gravitational potential energy is mgh divided by mg into 2h. When you will rearrange properly, when you multiply mg into 2h, you will get answer as 2 mgh. So children, you can observe here the numerator and the denominator is same, but this is twice than this. So mgh and mgh will get cancelled. So 1 by 2. So the ratio is 1:2. Okay. So this is about the first lesson. First problem. Next question is, find the gravitational potential energy of 1 kg mass kept at a height of 5 meter above the ground if what is there after if gravitational force G is equals to 10 meter per second square, then we have to find out what we need to find out. We have to find out gravitational potential energy. We have to find out gravitational potential energy here. So we know they have given the mass of an object, that is 1 kg, and also they have given the height of the object. So the given things we have to write first and then mention the formula of potential energy, that is mgh, and then substitute the value of m, g and h. So m is 1, so 1 we have substituted. G is already given, that is 10, so substituted as 10, and h is given height, that is 5, so substituted here 5. So when you multiply 1 into 10 into 5, it is 50 joule. So why it is 50 joule? Because joule is the unit of potential energy. So what is the gravitational potential energy? Final answer, it is 50 joule. Now come to the next third example. A box of weight 150 kilogram force has a gravitational potential energy stored in it equal to 14,700 joule. Find the height of the box above the ground. And they have given, take G is equals to 9.8 Newton per kilogram. Okay. So here children, they have given the gravitational potential energy. You can see here J is given, that means joule. So 14,700 joule is given, that is gravitational potential energy is given. Then we have to find out force of gravity, because here we don't know H. So force of gravity is nothing but mg. Force of gravity is nothing but mg. So m, we know the mass or weight, that is 150, and g is also given, that is 9.8. So right here 9.8. So now mention the formula of potential energy, that is mgh. We know that the gravitational potential energy is given. So substitute this value. This value is what? 14,700. So we have substituted the value here. Okay. And mg, already we got. Mg is nothing but what? Mg already we got. Here you can see mg is 1,470 already we have got here. So that you have to substitute instead of mg. So 1,470 height is as it is, because we have to find out height. So now when you transfer children to that side, you know that this multiplication changes to division. So 14,700 divided by 1,470, obviously you will get answer 10 meter when you cancel it. So height is 10 meter. So this is the final answer of the question number 3. We'll move to the fourth question. A body of mass 5 kg falls from a height of 10 meter to 4 meter. Calculate the loss in potential energy of the body. The second one is the total energy possessed by the body at any instant. At any of the instant you have to find out. So G is mentioned here. G is given as 10 meter per second square. Okay. So let us first see what all things are given in the question. Very important is you need to understand the question very well. Then only you can able to solve the given problem. A body of mass 5 kg. So mass of the body is given. That is 5 kg. Okay. Falls from a height of 10 meter to 4 meter, means the body was already on the top, now it is falling from 10 meter to 4 meter. Okay, so P at height 10 meter, when, because it is already at top, that means potential energy is there. So P at height 10 meter is equals to mgh. So we know that m is 5, g already it is given 10, so substitute 10, and h is already given when the object is at height of 10 meter. So we have substituted when the object is at the height of 10 meter, multiply, you will get 500 joule. Now when the object is at 4 meter, we have to find out what will be the potential energy. So P at height 4 meter, that is mgh. Substitute the value, m is 5 because it is already given here. G already given here. So that substitute here G, that is 10, and H is given here. So that you substitute here. So 5 into 10 into 4 is, it is 200 joule. Okay. So we have to find out now the loss in potential energy. So to find out the loss in potential energy, always you have to minus. So what was the, when the object is at height 10 meter, the potential energy is 500. When the object is at 4 meter, the potential energy is 200. So 500 minus 200 is 300 joule. So loss in P is 300 joule. So first answer we got. The second one is the total energy possessed by the body at any instant. Any instant you can take. We will take the first instant, that is 10 meter. Okay. The total energy possessed by the body at any instant remains constant for free fall. It is equal to the sum of P and K. We know that. What is mechanical energy? We know mechanical energy is the sum of P and K, and it is always constant. So it is mentioned here. So at a height 10 meter, that is at the topmost point. If the object is at height, certain height, so potential energy will be the maximum. We know that, and the K will be 0. But when the object is at surface, potential energy is 0 and K will be the maximum. We know, we have studied this in the previous class. So at a height 10 meter, that is at topmost point, K is 0 now here. So substitute the value now. Total energy is equals to P plus KE. So P already we have got here, children, that is 500 joule. So substitute 500, K is 0. So 500 joule again. So total energy is, again we got same, because at any instant when mechanical energy will be constant. So we got here 500 joule. Okay, next we'll move to the question number 5. Calculate the height through which a body of mass 0.5 kg is lifted if the energy spent in doing so is 1 joule. Take G is equals to 10 meter per second square. So after reading, children, we need to understand what all things they have given. If we read this, first they have given mass. Mass is 0.5 kg. Okay. Then they have given energy spent. That means whatever potential energy was there, that energy spent. Okay. Energy spent, potential energy spent is 1 joule. So energy spent is 1 joule. Okay. Now write the formula, because we have to find out the height. So we have to write potential energy formula. That is gravitational potential energy is equals to mgh. So gravitational potential energy is already given here. Energy 1 joule. So substitute that value here. So I have substituted. M mass already given, children, here 0.5 kg. So we have to substitute in M 0.5 kg. Children, G is given here already. You can see here, that is 10 meter per second. So we are, instead of G, we have substituted this value, that is 10. H we don't know. Okay. So now multiply this both. 10 into 0.5 is 5. Okay. So 5 into H is 5H. So transpose this 5 to the other side. Multiplication changes to division. So 1 by 5 answer is 0.2 meter. So height of the object is what? 0.2 meter, children. Okay. So can we move to the next question? Any doubt? Any doubt, children, till here? Till question number 5? Can we go ahead? Okay. So question number 6. A body weighing 25 kilogram force climbs up from the first floor at height 3 meter above the ground to the third floor at height 9 meter above the ground. What will be the increase in his gravitational potential energy? Take G is equals to 10 Newton per kg. Okay. So children, again we should see here what all things are given. Okay. So check here first what is given. We don't know here. Height is not given. We know that mass is given here, that is 25 kg. Okay, so M is 25 kg. Then gravitational force is given, that is 10. So force of gravity on body we'll find out first, that is mg. Okay, mg, M is 25, G is 10. So multiply. So it is 250 Newton. So force always unit is Newton. So N, 250 N. So now increasing potential, gravitational potential energy we will find out. So that is, we know formula mgh. Why we have taken here h2 minus h1? Because children, you can see here climb up from the first floor to height 3 meter above. So there are the two heights. So h2 minus h1. So floor at a height 9 am above the ground. So two heights are there, that is 9 and 3. Okay. So h2 is 9 and h1 is 3. So 9 minus 3 is 6. So when you multiply this both, 250 into 6 is 1500 joule. So 1500 joule is the potential, gravitational potential energy of the given object. Okay. So the next question is question number 7. A vessel containing 50 kg of water is placed at a height 15 meter above the ground. Assume the gravitational potential and energy at a ground to be 0. What will be the gravitational potential energy of water in the vessel? So they are asking potential energy of the vessel. Okay. So children, a vessel containing 5 kg of water. See, they have twisted your question. Actually, the weight of the vessel, including water, is 50 kg. Okay. So they have given 50 kg weight because inside water is also available there. So M is how much? 50 kg. Also, it is mentioned height, that is H, 15 meter. So now gravitational potential energy is equals to mgh. Okay, the formula we have written. Now we know mass, that is 50. G already given 10. So 10. H is 15 meter height. So all you have to multiply. So when you multiply 50 into 10 into 15, the answer is 7500 joule. So the gravitational potential energy of water in the vessel is 7500 joule. We'll move to the next question, that is question number 8. A man of mass 50 kg climbs up a ladder of height 10 meter. Calculate the work done by the man. Second one, the increase in his potential energy. So G is given here, that is 9.8 meter per second square. So first we'll see what all things are given. So it is given here mass 50 kg. Okay, mass of a man 50 kg is given. Okay, climbs up a ladder of height 10 meter. He is climbing a ladder. height 10 meter. Okay. So calculate the work done by the man. We have to calculate the work done of the man. And also the increase in his potential energy. That also we have to find out. So children, we know that work done by man is nothing but potential energy. As I have given you the example in the previous slide, when the Ningan Gowda was moving from first floor to second floor, he is doing some work. Work done is nothing but potential energy. So mgh. Okay, so m is 50, g is 9.8, and height h2 we have taken here, that is 10. So substitute. So 4,900 joule is the work done by the man. So now increasing his potential energy we have to find out. So we know that height is 10 meter. Reference point is ground, we know. If a man is climbing a ladder, that means initially was on the surface of the earth. So surface of the earth means height will be 0 only, obviously. So 0. So now gravitational potential energy is mg in the bracket h2 minus h1. So 50 into 9.8 into 10 minus 0. So again answer is same. So 4,900 joule is the increase in his potential energy. Now we'll go to the question number 9. A block A whose weight is 50 Newton is pulled up a slope of length 5 meter by means of a constant force F. An illustrate figure is given here. Okay. What is the work done by the force F? Is moving the block A 5 meter along the slope. See here, figure is given. Okay, block is here. Block A. He is moving that block A from certain point to certain thing. By how much has the potential energy of a block A increased? Account for the difference in the work done by the force and the increase in potential energy of the block. So first of all, children, force they have already mentioned. The force is 200 Newton. Sorry. Force is 150. Here it is mentioned 150. So force is 150. So the first question, work done by the force is moving the block 5 meter along the slope. That is force into displacement. Okay. So this is the formula. We know that. Force into displacement in the direction of force. So force is 150 already it is given. And the displacement is 5 meter long. So when you multiply 150 into 5, it is 750 joule. So the first answer is 750 joule. The second one is by how much has the potential energy of the block increased? The potential energy gained by the block. You know that U is a symbol to denote potential energy. Potential energy is the symbol denoted by U. U is nothing but potential energy only, don't get confused. So U is equals to mgh, where h is equals to 3 meter. Now this side, you can see 3 meter. So mgh. Okay. So now here it is given, again changed, 200 Newton. So 200 into 3, that is 600 joule. Third one, the difference, that is 150 joule increase energy is used in doing work against friction between the block and the slope, which will appear as heat energy. Obviously, when you are dragging something on floor, there is a frictional force also is hidden there. So friction between the block and the slope, which will appear as a heat energy. And we know very well, when we are rubbing anything, heat energy is produced. Next. Find the kinetic energy of a body of mass 1 kg moving with a uniform velocity of 10 meter per second. So can you tell me, children, one of you, what all things are given here? Can you tell me in the question number 10, what all things are given? Any one of you. Unmute yourself and tell me what all things are given.
Mass is equal to 1 kg.
Mass is 1 kg again.
Given.
Mass is given. Then again, what is given?
Velocity, which is equal to 10 meters per second.
Yes.
meteor per second.
Velocity is given. So now children, which formula we have to use here? MGH we have to use? Which formula we have to use?
Half mv square.
Half into
Mass into velocity square.
mass into velocity square, because now it is a kinetic energy, it is not a potential energy. Very good. So now the formula changes. That is half mv square. So m 1 kg, velocity v 10 meter per second. So kinetic energy is equals to half into mass into velocity square. So half into mass already 1, velocity 10 square. So 10 square is 100. When you will cut this, 2 ones are 250 is 100. So kinetic energy is 50 joule. So again you know that J is unit of, joule is unit of kinetic energy. So only problem solving. Okay. Question number 12. Two bodies of equal mass are moving with the uniform velocities v and 2v. Find the ratio of their kinetic energies. Okay. So they have given two velocities, two bodies they have given, and the mass of the both the bodies is equal. They have mentioned, but the velocity they have given differential. Okay, we have to find out the ratio of their kinetic energy. So velocity of the first body, that is v1, is equals to v, and velocity of second body v2 is equals to 2v, and mass we can write m only, because both the mass is equal. Since mass are same, kinetic energy is directly proportional to the square of the velocity. Okay, so hence the ratio of the kinetic energy is k1 by k2. This is there. So v1 square by v2 square. So v1 is nothing but what? V. So substitute v1 means v. So square as it is. v2 is what? 2v. So when we are substituting 2v, the whole square. So v square is v, 2 square is 4, and v square. So now v square get cancelled. So we got the answer 1 by 4. So the ratio is 1:4. Okay. So till here we have completed, children. So till question number 12. So tomorrow again I will continue with the problem solving only. Okay. And then I will complete current electricity problems, and then we'll move to the machine. Okay. Okay, children. Any doubt till here? Go through, study regularly. Okay. Okay. We'll call it for a day. Thank you, everyone. Have a nice day.
Have a nice day.
Yeah.